Okay, so the next thing we're gonna go over is the
An N3 like that.
epoxide formation from alkene. We could use carboxylic acid or MCPBA.
That's alternate way. I'm looking at this one. Pressure. I wrote it down.
I've never seen pressure in the
So let's say we had
come up. But my hand is stuck.
there. So if you see RCO3 or MCPBA, this is going to form an epoxide from the alkene. So the epoxide could either be a wedge or a dash. I'm going to say that this epoxide, that one is going to be a wedge. And so, since I made the epoxide a wedge, the methyl group would have to be a dash.
Okay.
And from this epoxide right here, you could do a lot of reactions, depending on what kind of conditions you're in. If you're in acidic conditions, which carbon would the nucleophile attack in acidic conditions? The more substituted carbon or the less substituted?
More high pressure.
Yeah, more substituted. So, let's say you have...
I was just telling you that's what it is.
Yeah, I'm not saying.
Okay, so then after we add the LiAlH4,
So let me draw the mechanism for the acidic conditions. So in acidic conditions, this oxygen here is going to get protonated by the acid. In this case, it's H2SO4.
Oh, it reduces it to. That was what I was saying before. Here. Nope, just
Positive. And the reason why in acidic conditions we want to attract the more substituted carbon is because we have a good leaving group now, and we want to make the more stable carbon-cation, which is the more stable carbon here
You make
of the
N3,
epoxide.
right?
Then we can bring in our alcohol.
oh, got it. So that's how we get the NH2. Okay, that makes sense because we need the NH right there. And then we put it in
And that would
water,
attract the more substituted carbon and pick up the epoxide.
which is what makes it an NH. Yeah, the water doesn't matter.
And this is an SN2-like reaction where it would invert the stereochemistry of the group that left. So since the group that left was a wedge, we're going to make this alcohol group a dash. And that means that the dash wedge, dash methyl here would convert into a wedge methyl. And this carbon here holding the oxygen epoxide will remain as a wedge.
Oh, PY is period.
And then we could deprotonate this oxygen here to make it neutral using the conjugate base.
For the water, though, that might be the workup. I think that might be the workup. Because with
And since we reformed our catalytic acid, we're going to use that catalytic acid to protonate this full minus charge.
this workup, that's maybe where it comes from.
So you get the OH. I think so. I think it ends up being an NH2 with the OH in here. And then we add this in, and that's what.
It automatically adds in because this is the same reaction. I
In
think pump
basic
needs to
conditions,
be-
we don't have this first step of protonating the epoxide oxygen. So
Let's
what
do
we're
this
doing
one.
is we do
It
SN2
says-
reaction where we look for the least
to get from N3
sterically
to
hindered
H2,
carbon,
you need
which is the less
plus
substituted
H2.
carbon
I'm
in
wondering
the
if the
epoxide.
H2O is just the H plus workup. Because then you go from NH2, you add that, and then you get that, which would give you.
And since this is SN2 like, the nucleophile that attacks the epoxide will invert the stoichiochemistry of the
So I think this
leaving
is
group,
3 plus
which is
1.
going to convert this wedge
And
into a
then
yeah.
5. 5 is the one where it attaches.
Then that means the oxygen here of this carbon will remain as a wedge.
You're tricking the fuck out of me. Dude, just do this. This is what I mean. You had that at first. That was right.
And we could protonate that
You raced it.
using the solvent.
You know, but now that you're gonna be like, or we're looking
Giving us the
Okay.
CH2 is not very
Same, same problem.
So you notice how here the difference between acidic conditions
Awful.
and basic conditions is that the nucleophilic alcohol
Okay, so I see
is attached
1,
to the
2,
more
3,
substituted side of the carbon in acidic conditions, but it's attached to the less substituted side in basic conditions.
Okay, I'm assuming
Yeah,
it's
that's
the
the
same.
difference, and here's the mechanism of why that happens.
Because we have a CL. We're basically just skipping the first step, right?
Yeah. So I think the first one's gonna be the NaN3 group. Sorry. To give us this N3. And we're gonna want like a lithium.
We have like 2 more reactions of chapter 11, and then we can move on to chapter 13. Do you guys prefer doing another practice problem with this, or just move on to the next reaction? Practice problem? Okay. Let's do practice problem.
7.
Yeah. Sorry, we got this.
Same. Okay, so this is NH2.
This one I'm confused. There's 4 there. But the other one is 3. Let's try and change. Unless you have to add on a
Probably have to add on.
let's see. So I would add an extra carbon.
Yeah.
But, so, okay, I think that's what you have to do first. I think you have to add a cyanide first.
They add a what?
CN. Yeah, I'm trying to remember.
Try this practice problem, and I'll do it at the same time, and then double check the answer at the end.
So this like before the like around 5. So if I have
Sounds familiar, but I don't know.
but based on this, there is
This is from. Oh, it's from.
but I don't know, I like drawing like on like this.
Yeah.
I guess there's a guy down there too.
Oh, I forgot the methyl, but I was so close.
You're so close.
I forgot the methyl.
Oh, this methyl group right here?
Yeah.
Yeah. That's good. You notice how here
yeah.
that the nucleophilic alcohol added to the more specific carbon? Yeah,
Yep.
but you got it. And it's
Yep.
anti-addition as well.
I was close.
Yeah. And also plus the enantiomer.
Yeah.
So I don't know.
I understand 2, 3, 4, like
You
down.
did the
I don't
mechanism ahead.
understand that.
Yeah, I know. I
think
need to
I know
probably
what it
start
does.
working it out.
Adding on the-
I'm not good at that.
Well, as long as you know the tricks, like as
Yeah.
you can add the more sensitive carbon, then
Yeah.
you don't need to do the mechanism unless the problem asks you to.
That's what I'm worried about. That's what I probably should do the
I might
mechanism.
just
Yeah.
Google it.
I'm gonna take a picture of it.
Yeah.
Two equivalents from step 3.
So for the next two reactions, I don't know if you need to know the mechanism for it, which is the osmonium tetroxide or dilute KMNO4 and ozonolysis. But I have the mechanism here as well.
I'm just gonna Google.
No, look up what DCA.
I think they're more predictive product reactions for the last two.
The ozonolysis, that's just so you get an oxygen on the more substituted, right?
Oh no, ozonolysis is when you cut the double bond in half
Oh, yeah.
and add oxygen.
Yeah, never mind. Forget what I said. I was thinking, what was I thinking of?
Yeah, so this is
I think you think of
like
oxygen
live.
migration
I was
dehydration.
oxygen
Yeah.
because you don't want rearrangement. We already did that one
Replaces it
though.
with
Yeah.
Okay.
So we're getting the first one, which makes sense because you have to add a carbon. You're getting CN, because that's your step 1. Step 2.
So probably add all that extra carbon.
Say again?
Probably add all that extra carbon.
What is right there?
Oh.
That is extra. Because here there's only 3 and here there's 4.
You're gonna get a better score.
So when I actually see the answer, I'm like,
No, I'm not.
yeah.
You both know that you're doing
It's funny because I see the answer.
on the
I'm like, okay.
reactions.
But
So
trying
I
to
gotta
get
change it to the NH2, right?
there. I think so. I'll look through my notes really quickly.
Yeah, so think of the epoxide reactions as like the nucleophile is anti-addition to the water. So we see out here the alcohol attached to the wedge. The other group is a dash.
Yeah, but
so
I was
the
like,
opposite.
with the hydrogen, with the hydrogen, I thought like maybe the stereochemistry switched again.
Oh no
But
no
no,
yeah.
it's
So
like
for
that.
this reaction here, this is just an acid-base reaction
Yeah.
where the base grabs the hydrogen and neutralizes the oxygen.
Makes sense.
Oh, okay.
So you get that.
The inverting the stereochemistry is only when you do SN2
then,
reaction, like it attacks the carbon and kicks out the leaving group.
Oh,
Okay. Makes sense. That
Vicinal diacetyl.
it looks like it's going to be one of those multiple addition. Remember how this one you add on like a mushroom? It might be like that. Because you turn the CN into. Can you turn it into polyamine and then just add like methyl chloride?
yeah, I don't know what it was. I was like, gonna go say.
CH3,
Yeah, and I'll be like, hey.
because then the CH will just keep bonding there. Oh, it's green already. That's just a hydrogen. So in solution, so when it says like H plus, like acid, right? H plus isn't like floating around.
Yeah.
It's always it's hydronium, which is H2.
So whenever you see
I assume that's
KMNO4,
just,
there's two reactions
probably just
to do depending on the temperature you're in. if you're in
giving
cold
way to
temperatures, less than room temperature, then you're going to add alcohols on both carbons and alkene on the same side. So they can either be wedges or dashes.
You could probably just write
So let's
heat
draw that.
plus
Yeah.
kind of like heat.
So let's say that the alcohols add as a wedge. And these are synaddition, meaning that they add on the same side. Since I chose the alcohol as a wedge, this methyl group on this carbon will have to be dash.
Yeah. So I think what's happening here is you're adding an
Oh, greater
oxygen
than that.
and then you're turning to a chlorine.
So K-4 is a strong
Sorry,
oxidizing
yeah.
agent, which means that if you're in
No, no, wait.
room temperature or
Because I think Cl. No, because
condition,
SO2 only
then
attacks
you're
up
going
here.
to cut open
To A, it
the
only attacks
double
the
bond
oxygen.
and oxidize it to a ketone or a carboxylic acid. So we see how here this carbon here has one hydrogen. Where I'm going to say this is carbon 1, 2, 3, 4, 5, 6. The double bond between carbons 1 and 6 broke in half. And then we oxidized the carbon 6 to a ketone and carbon 1 to a carboxylic acid. This is 1, 2, 3, 4, 5, 6. And to redraw this.
Why is that?
Yeah, so this is because K-4, think of that as a strong oxidizing agent,
Oh, okay.
which oxidizes
Okay.
the
So
carbons and adds more oxygen bonds
Oh, okay.
to the carbon. Yeah,
It acts as O3.
yeah, it's like O3, but in O3, you know how when you cut this one in half,
Yeah.
you have the ketone and
You
in this
form
case,
an
you just have an
aldehyde.
aldehyde.
That's a carboxylic acid.
Yeah,
That's right.
this is carboxylic acid because this is stronger than O3. It's stronger oxidizing agent than O3.
Okay.
But I don't know if Mr. will test you on this reaction. She might, depending on the temperature that she gives you.
I think there were some practice ones with leave-ins that had that, right? Is that what we were talking about?
so H3 plus.
So if you draw the answer like in this way, you get full credit. But if you have time at the end, I would redraw it. So it's easier for the grader to grade.
Okay.
But just draw this first and then move on to the next problems, and then if you have time, redraw it. And you don't need to worry about the mechanism for this reaction.
She won't test this on
No,
me?
you won't touch the mechanism.
I was like kind of scared that she would.
No.
Oh, quick question.
Yeah.
Here. So this is 118C.
Yeah, 118C.
So we have the nitrile here. How? I can't find this in my notes. What adding the hydrogen?
Yeah, so nitrile, this is from the previous midterm chapter reaction, is a carboxylic acid derivative cousin. And then whenever we add acid like H2SO4, H2O plus, or anything, we hydrolyze that back into the carboxylic acid.
Got it.
So that nitrile would turn into the carboxylic acid.
Okay, I see.
Yeah.
That makes so much more sense because then that's how we attract the S. You were saying it only attracts when there's no H group on it.
And the reason why we added heat is because nitrile amides are like very reactive, so we need to add more energy for the reaction to happen, which is
Got
heat.
it.
Thank you.
Let's go over the osmonium tetroxide reaction now.
Oh my God, that makes so much more sense. It sounds like, how did you get that extra carbon right there? Oh my God, it's like that, and then you do your workout, and that's what you get, right?
It tells you if it's the carbon. So I think they
Turn into a coin.
Yes, exactly.
And then 3.
So doesn't that then
So whenever you
adds
say
the carbon
OSO4 or
onto it, right?
osmonium tetroxide, this is also vicinal diol synthesis. That is synaddition on the same side.
This was an ether.
So let's choose, this time the alcohols will be wedge. So wedge alcohol here, wedge alcohol here. That means that this methyl group would have to be dash. this dash alcohol here, dash alcohol there. That means that methyl group there would be a wedge. And this methyl group.
Okay, yeah, that's what adds
He
it.
dashed, right?
So you have that, and then it tags.
Yeah, so this
Adds
alcohol was a
on
dash,
methyl.
meaning that this would be a wedge as well.
And that's how you end up with the one
Or,
wedge.
yeah, sorry. I said
This is synonym.
dash,
mixed it
but I
up.
meant wedge.
Yeah.
This one's always thin, right?
Yeah, this one's always thin.
And then it adds that one like that.
So,
And then you need HP for those.
did Nisiri emphasize the mechanism, or did she gloss over the mechanism for this?
I think so too.
Hold on.
Because I have the mechanism here as well.
I think there was one similar to it.
Similar, yeah.
But I think you did it. I'm not sure that she did.
I'll just go over it just in case.
It's like this one, right? Similar, but
Yeah, she did go over it.
She did go over it? Okay.
Yeah.
it's like this one, right?
I think I actually saw her when I went to look at my.
Oh yeah, so this is a different reaction. This is with H2PD, which is hydrogenation, where we add
She was
hydrogen
Where's the lab
to
coat? Like all the time.
both sides of the carbon and reduce it all the way down to the regular alkane.
Yeah, she always
She's
wears
like-
lab. She teaches all of her life. She's a lab
She's
coat.
like kind of petite.
Yeah, she's very tiny.
And
She's a tiny little old mean lady.
I don't know.
Never had her, thank God.
She's really nice, actually. It's
Really?
just
I don't know.
her.
I heard the reputation.
She's so
Her
sweet,
test-
she's gonna
yeah.
fail half of us.
That's the thing
So
about
a
her.
shitty reputation.
No, she's a really nice lady.
I didn't say she's mean.
Oh.
She sounds like
I mean,
a
I
mean
understand. I understand.
She's scary.
Nisiri?
Yeah.
Her tests are hard.
Yeah.
Who's in 118B right now? B?
So,
C? B?
Oh my god. 2 minutes left for me. But I'll be back here 3 to 5. So let's go over this mechanism really quick. So,
I'm watching.
say weird arrows here.
Yeah, okay.
Okay, so we know that this
Yeah.
oxygen here has 2 lone pairs of electrons. One of the lone pairs of electrons will attack one side of the alkene.
Okay, so the NA
The other side,
is
the other
gonna do
carbon
that
alkene
thing
will
where
attack
it does this.
Yeah, it adds on the
that
M3.
oxygen.
Yeah.
And
And this
that's-
double bond
the
oxygen
BR.
here, one of the bonds will go to the osmotic atom there. And I'm going to number these atoms to keep track of what atoms are attached to which. So this is going to be 1, 2.
So it would go like that first because this is a plus and this is a minus. And VR is a plus, right? So doesn't that attack that?
Your is. Oh, which one's wrong? It's
VR is a minus?
yeah, it's underlined.
This is 1, 2,
Sure, let me just split it.
5, because of the way I numbered these atoms. We know that the ethyl group here is trans to the methyl group there. So that means that if we choose this ethyl group to be wedge, the methyl group would have to be dash here. Since these two methyl groups are at the cis side of each other, the same side, this methyl group would also have to be dash right there.
Sure, because we don't go over
Okay.
the chemistry.
And then
Okay, I know it does this.
I know what it
this is
does.
the first
I
step.
can
The
draw it.
second step here is the
draw
reduction
this
step,
out?
where we could use H2S to reduce this
Why not it kicks it off? So maybe this attacks
Down
here and it kicks this
into-
off like that.
the
This
alcohol.
is good
So we get
line.
rid of this osmotic and
Here. Yeah, it
carbon
attacks the
double
Yeah,
construct.
okay, yeah.
so it attacks the
That's what carbon's attached to and it kicks off the VR and that's how we
alpha
get this.
carbon. Yeah, and then you get. Well then, do you
We could redraw that.
draw the reaction?
So I don't think you need to know the mechanism for the second step of reduction. You just know that that second step
it's
of reduction
just a small
H2S
one.
or
It doesn't
CH3-2S
participate.
will reduce this 5-membered ring, get rid of the osmonium and 2 double bonds of oxygen, and add alcohol.
So we get the
And you see how here this is in addition because the oxygens here were added on the same side in the mechanism, like in this concerted step right here. The two oxygens were added on the same side, and that's why it's in addition because we have the alcohols on the same side. And then I just redrew it here. It could be dashes or wedges.
There's 4 bonds, and
Okay,
2
so
bonds,
for this
2
one, we'll
bonds.
put an enantiomer or
This
no?
attacks.
Let's see, we have a chiral center here, chiral center here. So yeah, we need to
Well, because it's important.
No, it's not.
Centers we do.
And then you lose nitrogen gas. and
if there's at least one chiral center, we can do plus enantiomer. At least one chiral
look at
center
the
with
test.
yeah, one plus. Give me one,
Wait,
two,
doesn't this
three,
attack
4.
here and then attacks like that?
Oh, it also depends on, let's say, you had a chiral center here as well.
What if there's a non-reacting?
Yeah. If there's a non-reacting chiral center like this,
I just don't know if it changes.
then you can't get plus enantiomer because the
Just
enantiomer
get
would flip
NA.
everything,
We get
and we don't
NA.
want to flip this.
Minus. Then
So
it attacks
I would draw
Well, this
the
is
other
just a side
structure, but
right?
flip these reacted carbons.
So it,
What's the name
no,
of
no,
this
this is
reaction, or do we need to even know it?
The
So
name
what happens
would be
is,
like vicinal diosynthesis with osmonium tetroxide.
attacks
I wouldn't
and
like
get
memorize the name of the reaction. I just recognize what reagent we
R
have,
because that's
OSO4,
like
which is a sign of adding 2 hydroxy groups on the same side, syn addition.
and you get
What's the definition of vicinal again?
Yeah, a syn is same.
Vicinal.
Oh, vicinal, yeah. Vicinal is a position term where the groups are adjacent to each other. So this alcohol is adjacent to this alcohol, which is vicinal to each other.
and then
Yeah, no
the
problem.
next step you lose.
Okay, I'll be back here
nitrogen gas.
3 to 5. Yeah.
What's her name again?
Projection.
Newman projection? Yeah.
I
Yeah.
feel like she's gonna. There might be one on there.
Yeah, there was one when I took the exam.
Okay, yeah.
Yeah. Let me do that right now.
Toss it in there.
She's definitely gonna throw one in. I can feel it.
I feel a Fisher projection and Newman projection.
Yeah, Fisher, I can't like. It's 50.
Maybe actually you're right. Maybe Fisher projects. I don't know with her. I feel like she's gonna ask something about racemic mixtures and the percentage. I'm just gonna sit there and be like, pass, hard pass.
I thought the practice exam I failed like all of the problems multiple places.
Same. I did the even one. Oh shoot, we're recorded already.
Okay, so this problem here, she could say predict the product and like draw the Newman projection of it. We have a strong bulky base and a secondary substrate. What reaction would this be with a strong bulky base with a secondary substrate?
E2.
E2, yeah.
Hoffman?
So Hoffman. Which hydrogen would we grab? Would we grab this hydrogen or this hydrogen? The left one. Yep, the left one because it's more. More like free, less like hindrance. We're going to double one there. Pick up the leading group. Giving us the Hoffman product, which is the least stable double bond. So now let's do the Newman projection between this carbon and this carbon here. I'm gonna say that this is my eye, and I'm gonna look through these 2 carbons here. So I'm gonna label this carbon 1, carbon 2. Carbon 1 is going to be this middle carbon right there. Carbon 2, I'm going to draw as a big circle behind carbon 1. Carbon 2. Okay. Now, what other atoms are carbon 1 attached to besides carbon 2?
So like electronegativity creates like a dipole.
Like what other 3 atoms is carbon 1 attached to?
The weakest bond is after carbon bonds with the and you have like
Yeah. So we see this carbon 1 is attached to a carbon, and it's also attached to 3 other groups.
Yeah, so 3 hydrogens.
Yeah, 3 hydrogens. So we can draw the 3 hydrogens here, here, and here. Carbon 2 is attached to 1 carbon, BR, and this CH2, CH3. For E2, we want anti-periplanate transition state, which is the hydrogen on the opposite side of the bromine. So let's say that this hydrogen that we grabbed here is this hydrogen here. Since we want the bromine to be on the opposite side, we're going to have to place the bromine down here to make this bromine on the opposite side of the hydrogen that we grabbed. And then this carbon here is also attached to another hydrogen and a CH2CH3 right there.
Does it matter where you put the B or like does it have to be in a certain location?
In this case, it doesn't because we have the first carbon has 3 hydrogens. Where let's say we added the Br here, then that means that this hydrogen would be grabbed. But let's say that we didn't have that those 3 hydrogens, and we had 2 methyl groups attached to that. Then
I guess that's it.
we can say that these are the 2 methyl groups.
Oh, that's cool. Yeah, sorry.
Then it wouldn't matter because we want this bromine to be on the opposite side of this hydrogen here.
like a little decoration from the canvas.
If we place the bromine here and hydrogen here, then this wouldn't be anti-periplanate to each other.
Okay, got it.
Because there would be gauge, like which is very close nearby. Let me see what kind of question this we might ask on the Newman projection.
So I can't really like understand
That'd be
lectures.
Untitled.
But I do like her in chemistry.
I don't know.
No, she said, boron is ungrateful brat.
Is that staggered or
Is
eclipse?
that right?
This right here is
Eclipse come?
staggered.
Staggered?
Yeah, because eclipse would look like this right here.
They'd be closer, right?
Yeah, it would be closer to each other. Let's say this.
Okay.
Where they're like basically
Full on
touching each other.
360.
Yeah. Let's say exam 1. Here, I'll show you guys my previous one, which is this right here. Write the major organic product for the following reaction. Also write the mechanism of the reaction of the Newman reaction. So we see that we have an E2. We formed a more stable double bond because we have a small, strong base.
Oh, all the hydrogen?
And I drew the Newman projection here where the base gets that. So we have a bulky base here, which is carbon oxide. This will deprotonate this hydrogen, form a double bond between carbons 1 and 2, kick out the leading group bromine. And that is what, like, basically what I had for my exam.
She asked me to do this all in Newman projection. The whole mechanism in Newman projection. I'm just gonna cry.
I think this is a question she had on the picture projection as well. The one with the vertical line and a lot of horizontal.
Yeah.
Yeah.
Well, I know they're all wedges on the sides.
On the sides.
And the dashed are the.
Yeah, I think of it as giving you a hug. Yeah.
Yeah.
Yeah, like
That's
those
just
as little
positive
arms.
thinking. Yeah, it's because you have to find the.
Yeah. So which one do you want to go over? Which?
Oh, the RNS clear.
Yeah.
Oh, this is not the product right
That's
here.
how you do it.
RNS is annoying, dude. Honestly, sometimes they be trifling. Like sometimes easy, sometimes not.
Oh, here's an ether.
And
Yeah,
then
I
to
see.
do
I
that,
see.
then
Okay, let me show you the mechanism for that one.
The trick I
Yeah.
think for RNS is if your functional group is dashed, put the hydrogen as a wedge, and then you switch
But I
it.
thought you always, but I thought.
So like if it's like
Oh, so if it's on the top, right? You're saying that.
this is your hydrogen, this is your bromine.
1, 2, 3, 4, 5.
So you would normally do 1, 2, 3, 4, right? So this looks like it was R,
Okay.
but it's really S. Because you have to switch this of that. That's the trick that I was taught. Is, instead of doing like how some people will teach you to like switch the orientation, they don't do all that. Just switch your direction.
Yeah.
But I'm sure on the exam,
Do you guys
there's
remember it?
something like that.
Yeah.
Take it with a grain of salt.
So I'm going to draw out this mercury with the 2 oxygen acetate groups.
N3 plus, right?
Yeah.
So that needs to get deformated. And
And draw the reactant down here.
If you didn't have that second
Since this mercury is attached to two electronegative oxygen atoms, would this mercury be positive charge or negative charge?
Positive.
Positive charge. So this has a partial positive charge, where the alkene will attack that mercury, kick out this good leaving group at the same time, the acetate. And as mercury is gaining more electrons from the attack, the alkene is losing electrons. So then the mercury will come back and attack the other side of the alkene at the same time.
That sounds good. So instead, we add a second N3.
Because mercury is becoming more nucleophilic as it gains more electrons, the alkene is becoming more electrophilic as it loses electrons.
Oh, okay. That's really interesting. So let me write this down. So NH3 ordinary
And the reason why this acetate is a good leaving group is because
okay, so
yeah. Why do you think this is a good leaving group here? This acetate here. When it leaves, it becomes this acetate group. And why is this stable?
why is it? Oh yeah. So
Why is it stable?
Yeah, why is this molecule stable?
Resonance?
Great, resonance. We see here this negative charge can do resonance.
There's a meme on the Discord about that. Just say resonance. Wrong.
For like everything, resonance.
And since these electrons are delocalized, they can move around the molecule. This makes it very stable and happy, so it doesn't want to react and come back and attack again. So that's why this is a good leaving group.
Did she say anything else?
Okay. And now, usually the next step, we have either water or alcohol attacking the more substituted side of the ring, but we don't have water or alcohol in this case.
Did she move the
But we do have alcohol in the structure.
No.
Here. So we see this oxygen has 2 lone pairs of electrons
She moved the lab.
that can act as a nucleophile. It attacks the more substituted.
Wait, she didn't move. No, she actually moved the
Picks up the
exam.
mercury
Oh.
on the other side.
511.
Oh no. Yes. You're lying.
No, she did.
He's playing with me. She moved the She moved the
Three.
Maybe I'm just stupid and I can't read.
Oh.
Does that mean we're gonna chapter 14 on it too?
Oh no.
I think we might. She started teaching it today.
Wait, but that's actually
Can I
looking.
check the
That's
double
kind
check
of
the
good.
key for
Also,
this?
It's good but bad. You know that the lab. I don't know if you have you already had your lab this week?
1, 2, 3,
I don't
4,
have
5.
Oh.
I got you last quarter, but
I don't know. I like the labs are virtual this week too.
I forgot this carbon right here.
yeah, I'm sorry for you guys.
I actually really like the labs.
How do we know
No,
that
honestly, the labs are
alcohol
fun, but honestly,
is going
you're
to
just making
attack
crystals and then then drying them out.
Yeah, I like it.
So,
It's so boring.
And it's throwing them away.
No, I want to actually make like.
we know that once we form this ring from the alkene right here,
But like, I want to make meth.
these carbons
That was his goal when he
What?
went.
are electrophilic because this mercury wants to grab electrons since it's very positively charged, making these carbons electrophilic. Which carbon would give you the more stable carbocation? The more substituted carbon or the less substituted carbon?
more substituted?
The more substituted carbon, right? So we have to look for a nucleophile to attack. Usually in oxymercury mercuration, the first step we have water or alcohol that would attack that. But in this case, we don't have water or alcohol in the first step. But the alcohol, in this case, comes from the actual reagent itself. So when the nucleophile and electrophile are in the same molecule, that's an intramolecular reaction where the nucleophile attacks itself.
So if we have water, that won't happen.
So now
The
Yeah.
water will attack.
Yeah, the alcohol here, the OH.
Do you think she can move the data for second exam? Since it's only now like 2 weeks.
Because they didn't give us a nucleophile to attack with, so we have to look for a nucleophile within the molecule.
Give me a stomach ache.
Which is this negatively charged oxygen right here.
I was excited.
I went like this.
1, 2, 3, 4,
Yeah.
5, 6. Okay, I added too much again.
How do you know it's not the acid that just broke off?
So does that mean that?
Oh, this acid right here? Oh, this conjugate base just left right
How
there?
do you know that's not the nucleophile?
Yeah, this is not the nucleophile because you see after this negative charge is able to resonate
Because
around.
then we might just
It's
have
delocalized. If it is delocalized, it's very stable and unreactive.
material that we can continue on. Yeah, she
Yeah,
might do
because the
that.
next one's on the 25th.
Which Loki could be good though, because it's only be a little bit of material.
You don't think she'll move the dates?
No, because then that
that week later, like
It's finals,
2 weeks
right?
later, it's finals.
Yeah.
She wouldn't move it back.
Quarter's almost
Well,
done.
she could move it back, but
Really?
it wouldn't make sense for it to move.
Yeah.
It wouldn't make sense.
We know after this attack, we have a 1, 2, 3, 4, 5
It could be
triggering.
good though. Like I'm gonna get the prospect because like you're saying that means that second midterm might be a little bit
That means
less.
it's gonna be during my NPB exam.
At carbon 1, we have
For
at
that,
oxygen
for me to
1,
be
we
stressed
have
out.
a hydrogen
I
charge,
already had
that oxygen positive charge.
I planned out my exam days.
At atom 5, we
Yeah, I
have
have a midterm.
this methyl group
after Chem.
with the mercury. So this is after the first step. The second step is a reducing agent NaBH4.
Yeah, I did really good on the first midterm.
Whenever you have a reducing agent like NaBH4 or LiOH4, think of a hydride ion, which is a hydrogen with a negative charge.
Practice problem? We did them a couple times.
And then so let's say that this is the negatively charged hydrogen here. It will attack that carbon and just kick out this whole
Hasn't he gone over this?
Yeah, I've just gone
Oh,
over
the,
an example problem that's a little bit harder than the regular one.
Yeah, I had my sister done.
Sorry.
Oh yeah. Where's your last year?
Oh, it's another drug oxide.
Yeah.
And let's say this acetate group deprotonates the alcohol. But do these steps separately, like the reducing step and the deprotonation step separately to get the full points.
So why does the acetate attack or deprotonate if it's very happy being negative?
Yeah, so that we will use a better base instead, which should be let's say another version of these, like another oxygen of that could be the base instead. Since this is a weak base, it could be
Always.
yeah, just any base to deprotonate that.
Okay. Thank you.
Brian, I'm
Yeah.
sorry, I was talking. Why did the ring? How did we get a ring?
Yeah, so you know how normally in the oxymercuration demercuration reaction we have HEOAC, water or alcohol?
Oh, because it's not there.
Yeah, it's not there.
Okay.
So then, in the mechanism, we have to look for our nucleophile, which is going to be the alcohol within the molecule itself. So if the nucleophile and electrophile are in the same structure, then that's an intramolecular reaction where it attacks itself.
That can happen with the ozone, the O312, right? If there's no water or alcohol in it, it can attack itself.
For
Close
hydroversion
itself?
oxidation, yes.
Okay.
Yeah.
Yeah, for this one, but it can also, that same idea can also be applied to, like, when you have the O3, right? If it's just O3 and this is like a bond line structure, that's how you know how to close it, right? Is because the oxygen has to act as a nucleophile.
Yeah, so O3 and this right here,
Yeah.
I think of scissors cutting the double bond in half
Yeah.
and adding oxygens there.
Okay, but say this is just a line structure and this isn't here, you're just given O3.
Yeah.
Then this oxygen has to act as a nucleophile, so it would close the ring or close this bond line, right?
So this structure opening ring right here is the result of this second step. So this is a reducing agent. This is not a nucleophile right here. I'll show you the mechanism of that.
There was an example I seen, and I can't remember it, but it was basically kind of that same idea where the oxygen, but it was O3, had to act, the oxygen here acted as a nucleophile, and it closed the bond line into
Yeah, if you didn't have
cyclohexane.
this C32S, then you'll end up with this ring right here.
Oh, okay.
And you wouldn't go through all the way through.
Okay, yeah, that's what I knew there was a reaction where it was like this, yeah. Okay.
Yeah. we already went over the bisinol synthesis last time, right?
Yes.
Yeah. So yeah, the last reaction for chapter 11 is ozonolysis, which is my favorite reaction in this chapter. Yeah.
Canting fission.
Yeah.
Yeah, because you don't have an oxygen, so normally here there's another, you're gonna have alcohol or water, and that is what is going to, you're just gonna add it. But because you don't have that here, it's gonna form, this is gonna act onto this, and it's gonna close it. And you're gonna have this methyl group at the end. See, this is this closing, if that makes sense. Like this is coming off. And imagine this closing here. And this is going to leave here. So that's how you have this in the center. This is going to be off. And you're going to have that. That's that methyl group right here.
Does that mean diamonds are going to
This oxygen is attached to
But
this.
don't you have
I mean diamonds are already on midterm one?
So if you don't have it.
So it's in step 1 if you don't have it. Not step 2.
Oh, God, it's
I
a
would
step.
think so.
Yeah.
Because,
So,
like they were saying,
Got it.
give you another minute.
Then that, you don't have water.
Probably test it on the other time.
it's basically closing. So this is going to leave. This group is going to leave.
When there's like
And you're going to close it like, or you can
I guess
think about it
also,
closing.
like, if they've already made the midterm, then we'll probably just be testing on stuff until last Thursday, but if not, then we'll probably add
if
stuff.
they if they may add things.
So this is going to leave and leave it left like that, which is that oxygen here and that methyl group there. I don't know if you see it.
Yeah, no.
Okay.
Honestly, I think chapter 12 and 13 is like knowledge for one midterm, so
Yeah, yeah, the
I
methyl
would
group.
happy
That's a methyl.
just have it on this
So
That's what
I
I'm
guess
saying.
there's less pressure now. But then it means you have to be learning.
I feel like there's still more pressure.
I'm gonna keep that
So
anxiety.
for the ozonolysis reaction, we have an option with these two sets of reagents. The first step is ozone. Second step is a reducing agent like zinc or CH32S. What I think about in this reaction is there's cutting the double bond in half and adding oxygen at the ends of that. So the products here would get are this product and also this product right there. So that's why it's like my favorite reaction, because you just cut up the double bond in half and add some oxygens at the end. Redraw that. So if you draw it this way, you get full credit, but I would redraw it to make it like look more nicer for your grader to grade at the end.
She moved our exam.
Oh, she moved it?
Yeah.
Oh, to next Thursday?
No, she was sending me this.
Oh, that's like the same day for some when you can see people for next week.
I don't know if it's good or bad. She's gonna put more material on it now.
Oh yeah. Did she say that she's gonna cover more material after chapter 13?
She didn't, but I would assume.
I see.
They keep going.
Okay, keep going. Okay.
I have the same anxiety.
Okay,
Regardless.
okay. That's like the anxiety diminished or something.
Yeah, no.
Because that means that you just have to get more material.
Exactly. It's more to learn.
More to
She's
learn.
gonna have higher expectations. Of
Or she's gonna have harder
maybe
problems.
higher though, like you're already
Oh yeah, they could be higher. Don't say that. We're gonna get jinxed.
Oh, the reason was
She's gonna start asking for those harder mechanisms.
No, imagine the whole freaking midterm on mechanism.
do the full oxy
I would
mercuration,
cry.
demercuration.
She would definitely have to have her like balanced, like, because we only have so much time.
It's 50 minutes.
Yeah, it's from 9 to 9:50, right?
Yes.
Hey, what happened to the last part?
It was just this.
Simple.
You just break
Oh,
it
he
down.
already put it on.
Yeah.
Or I'll go in and take the exam for one of you guys.
Wait, what?
Say that.
Go and take the exam for one of you
Get out my
guys.
wallet here.
Don't say that. You're gonna be.
I know that sounds like that's kind
Just a joke, just a joke. Just a joke.
Just kidding.
But no, yeah, it helps. So it just gives us more time to review.
You should probably edit that out.
That's fine.
Yeah.
Hey, they don't know my name.
Yeah.
People get super serious.
Some people are like.
People get super serious here.
Yeah, each have to use the same. Once you get lab experience, okay, then other labs are more willing to train you.
Oh my god.
So, you know, okay.
Take a joke.
So the alkene could be in a ring as well, where the ozonolysis we just cut open that ring into one molecule. And we could either have a ketone if we have two R groups on the carbon, or an aldehyde if we have one hydrogen on that carbon, which is this invisible hydrogen over here. Can you draw that? 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6.
Oh, okay.
1, 2, 3. Okay. You gotta find more.
That's pretty.
Once you get one rejection, you'll probably get it.
I like these. These are easy.
Yeah. It's the mechanism that's the hard part of this
Yeah,
reaction.
I'm not worried about that.
Yeah. I don't know if Nusiri would go over it though. Like test it though. Did she go over in lecture the mechanism for ozonolysis?
Did she?
Yeah,
Did?
it's on there.
Yeah.
It's on there?
Yeah.
Oh yeah, sorry.
But I just don't know. Like, is she gonna quiz us on it? I don't know. But she went over it.
Yeah. Wait, what was my mechanism
What
problem?
chapter 4? So that means I have to go over. So that's not to do. I have to watch the lecture. I can't just do it.
But the ozonolysis isn't that hard, right? It's just lining it up.
Okay,
Is
just
the whole idea? Is lining
Well,
up
no, because
the
that's what I
three
do. I
oxygens.
skip it and then.
You want the orientation to be right?
Oh,
Yeah,
no, for chapter
lining up the 3
14.
oxygens
Yeah.
together. But after that is a little bit weird.
Oh yeah, this part, huh?
Yeah, where like we break open the ring.
Oh, I only remembered this first part of the mechanism. That sounds like, oh, it's not that bad.
Her lectures on.
Yeah, I wish it was that easy.
Yeah.
I read the notes.
I didn't even know this mechanism when I took the exam. I just like hoped it wasn't there because I didn't have time to study it. Yeah,
Aside from like the
that makes
Do you
sense.
mind explaining it?
Yeah, the mechanism.
Yeah, please.
Mhm.
And the off chance it is on there now.
Okay.
The mechanism for this one.
Oh, okay.
So once you master this, you're an ozonolysis ninja.
Heck yeah.
Yeah, no, I feel like I would just, because the people I know at least, I'm like, you guys are doing great, and then I would just leave, see, and get paid for hours. Let's say, for like the amount of work.
But the lab's still in virtual, right?
Yeah, you'll get paid for that.
For those that haven't already taken it.
You're welcome.
Val said it was going to be
And
virtual.
if they catch the person, you might still have it in person.
Well, to be honest, they've been dropping the ball.
I always
So.
forget about
I don't care if they can.
Yeah, I
I don't care if that person's out there. I still want to take a lab.
it. Like,
So we know
because a lot
that
of people have a great
this
time.
oxygen is negatively charged, which is the nucleophile. It will attack one side of the alkene. The other side of the alkene will attack the third oxygen. And then the double bond between these two oxygens will break off and neutralize this positively charged oxygen there. So it's like a ring around the rosy mechanism. There. Okay, does this step make sense so far?
Yeah.
Now this is the weird step.
sir.
We're going to make the carbonyl bond. And at the same time, this bond, the alkene bond is going to break off and make a carbonyl bond over there. And this oxygen to oxygen bond is going to break and go onto 199, one of the oxygens there as well. So then you would get
How far are you? But most of the whole. What do you think?
I took training.
okay.
Oh, you told me about that. You got a B.
What?
You got a B.
I got an A.
You got an A, didn't you?
I got a B.
I swear I heard it.
I had to write hella essays to myself.
Did you ever take Japanese? Or you took
In the slides that I sent you,
It has it pretty well described. Or the ones that he sent me.
What's that? Is it the one you're looking at?
These.
Oh.
It has a good
Sent it to me, so probably.
That was on a series notes?
No. This is the CH.
What are you doing,
the,
Simmons?
Oh, that one, yeah. That was when I took the notes for that class.
Yeah.
Oh,
You just
yeah,
you send it to them?
You want to
Yeah.
airdrop that to me?
Oh yeah. Do you want it?
Yeah.
See you.
Simmons Smith mechanism at all? It's
They're really useful. Like, it has
Yeah.
everything. It has exactly.
Oh, that one? That wasn't one on her summary sheet, so I don't think she'll cover that on the exam. But I would know it just in case she
it just
tries to trick you.
cyclopropane.
Yeah.
He's like, you should know that just in case she tries to trick you. I was like, oh.
Wait, what?
Simmons Smith.
Oh, I remember her talking about that.
Right, yeah.
For- it was
CH2,
cyclopropane.
I2.
Yeah.
And also with this I2,
We see I2.
yeah, it makes it cyclopropane, yeah. And you see how here these argues are trans to each other?
Yes.
I didn't
Then
say
that means
that.
that they'll have to be on the opposite side.
Same.
It
So
remains
can it be
together.
cis and we'll get a cis?
Yeah.
Cis
I'm
argues?
Right.
EPH
If it's cis, then it will
at
have to be cis as well.
Thank you. I think I'm just Julia.
Anti or anti, right? These
Julia's
would be
not
anti on the same.
Yeah, those will be anti to each other. Okay, so this negative charge oxygen here is the nucleophile that's going to attract this electrophile. We kick up the double bond onto the oxygen, which is going to attack the other carbonyl carbon. And
My CDS computer.
click this on here. Okay.
You took this in the summer, Brett?
Yeah, I did.
Jesus. This is
Summer
impressive.
session 1 I took 118A, summer session
Yeah.
2 I took 118B in 2021.
I'm taking the summer session to see over the summer, but I don't think I'm gonna do as well as you did. You killed this.
It was all online though, like that was during the COVID lockdown time. So it was open internet.
I was about to say they made it a lot easier.
Yeah, so I got to use my the Nursery made it like way harder though. Like yeah. But we get to like control F things, search up things online, look up the material during the exam.
I feel like I got cheated a little bit. I took like some chemistry classes there too, and it was always open note.
Open note.
Yeah, I didn't memorize anything.
I'll be there.
For general chemistry?
Yeah.
Let's see.
Cell and molecular too, bio. I didn't remember much. It was all open note.
Mine is CDS computer.
Try the iPad 2 one.
iPad 2.
Yeah, it says print
This is-
these two. Maybe. Or
There's iPhone 94.
Oh, okay.
No. Mine always says Julia, see? Or iPhone 3. That's also my other one.
Oh.
Oh, yeah. Thank you. Oh, these are really helpful.
Right? He took, or he does really well with notes. A lot better than what I could do.
Who's that? Right? Oh, these are
Right?
your notes?
Yeah.
That's what I said. That's what like he did this during the summer and he killed it.
I
I was
thought
like,
it
I
was
would not have
Jim's.
done it.
No.
It's high praise.
Yeah, all those reactions and mechanisms that I went over is basically another version of this, but when I made this, I just followed the series summary sheet. But that thing that you guys just got is like more comprehensive, like it's more detailed.
Yeah.
It shows like the stereochemistry and everything, selectivity.
Are you a chem major?
I wanted to be, but no. Like I want to be now, but I can't change it because if I change it, then I have to stay an extra year to complete the other major requirements. I'm biochem. Biochem major, yeah.
Wait, so for chem major, like, chem is just what?
Mm.
Like, what are you missing? Or what are you missing?
there's like other like more advanced organic chemistry classes, like Chem 181. I'm taking that fall quarter though, just to improve my OChem skills and like for
Just for fun,
just for
say
fun.
it.
Yeah, just for
Don't make, we're not gonna feel bad.
yeah, yeah.
Okay.
Because I could have graduated early, but I want to take anatomy and physiology before I go to my grad school.
Okay. Are you pre-med? I wish
I
could say that.
was,
Oh, okay.
I was,
I
but
wanted to graduate early, but
No, for
I wanted to take these classes for fun.
I got accepted into like chiropractic school, so I'm going there.
Oh,
Yeah.
congrats!
Yeah, thank you. Which is a lot of anatomy physiology, which is why I'm gonna take it.
I took anatomy at JC. It was a lot of fun.
A lot of fun.
Congrats.
I see. Thank you. Was it EXP or CHA?
I'm not sure. It was the for science majors.
Oh, I
But,
see.
I know at Davis it's more intense because you do dissections and stuff like
Yeah,
that.
cadaver lab.
Yeah, we had a cadaver lab right before COVID, so we didn't have a chance to
Oh yeah.
do
Yeah.
much.
I see. But you learned a lot.
Yeah.
Yeah.
I know Davis, it's like really hard, really difficult.
Yeah. In EMT school, you go over anatomy and physiology as
And
well.
it's helped a lot.
Yeah.
I heard the Davis one is a challenge.
Okay, so let's go over chapter 13 next time.